Gang, we're going to talk about independent and dependent events. So you should have OneNote in front of you, and let's just get started so we can keep this nice and short. If you need to press pause to take notes, feel free to go ahead and do so. Two events are independent if the outcome of one event does not affect the outcome of a second event. When more than one event is being performed, we multiply the probabilities. All right, so two quick rules there to help you with this next set of probability. In the last chapter, when we were talking about probability, we were talking about one event. You roll a dice, or you pull a card from a deck, or something like that. Now we're going to start talking about if we do two events. Whenever you do two events, you have to determine, are they independent or are they dependent? If they're independent, that means the outcome of the first one does not affect the outcome of the second. A common set of independent events are if you flip a coin and roll a dice. Getting a heads or a tails on the coin has no impact on the dice. They are two separate things. So we call those independent. And therefore, if we need to calculate, say we want to calculate the probability of getting a heads and then getting a 1 on a dice, well, the probability of getting heads on a dice is 1/2, or heads on a coin is 1/2. The probability of getting a 1 on a dice is 1/6. So to get the probability of both of those things happening, you would multiply and you would get 1/12. Right? And that's it, right? Pretty much. So if we look at the next example, we have a fish tank. And in our fish tank, we have red fish and white fish and green fish. We're going to find the probability of this event when we pick two fish. The fish are replaced after they're selected. So we would pick out a fish, we look at the color, and then we put it back in, and then we pick another fish. So in this case, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There are 12 fish in this tank. The probability of getting a red-white, well, there's 5 red fish times, and now we're going to put the fish back in and then draw another fish, and there are 3 white fish. So red-white would be 15 over 144. Green-green would be, there's 4 green fish, so 4 12s times 4 12s. And that would be 16 over 144. And then red, white, and green, so that's one of each. So white fish would be 3 out of 12. Red fish would be 5 out of 12. Green fish would be 4 out of 12. We would multiply all those things together and see what you get. I'm going to do a little bit of mental math here. The 3 cancels out the 12, which leaves me with 1/4. The 4 cancels out the 12, leaves me with 1/3. So I'm going to get 5 divided by 144. Right? And you don't have to simplify them, but that just works out pretty quick since I don't have my calculator. So here's another example. Toss a coin and roll a die. To roll a die, to get a 2 would be, oh, what happened? I gotta go back up. To get a 2 would be 1/6, and to get the tails would be 1/2. So that's 1/12. To get an even, that could be a 2, a 4, or a 6. So that would be 3/6. Heads would be 1/2. So that would be 3/12. A number less than 5 would be 1, 2, 3, or 4. So that's 4/12, 4/6 times 1/2. So 4/12. To get a 7, well, that's 0 times 1/2. So that would be 0. All right, so when you're multiplying, we have two different events. You multiply the probabilities together. The other type is called a dependent event. So if the outcome of one event does affect the outcome of a second event, we call that dependent. The most common example of dependence is when you select cards or anything without replacement. And this is generally the way you really play card games. When you play card games, games like War or 21 or something like that, you would flip over a card and then you would immediately flip over the next card. You wouldn't replace the cards. So if we're looking at the probability of getting, say, the 7 of hearts, followed by the Jack of hearts, followed by the 3 of clubs, without replacement, the 7 of hearts, well, there's one of those, so that's 1 out of 52. Then we want the Jack of hearts, and there's one Jack of hearts, but there's no longer 52. Now there's only 51. And then the 3 of clubs, there's still one 3 of clubs, but there's no longer 51. Now there's 50. So the bottom number changes each time, and then you would have to multiply all those together to get your final answer. So let's take a look at one with just 2 cards. So game of blackjack, 2 cards are drawn, not replaced. That's a key. That means these are dependent events. A 10-10. There are 4 10s, so 4 out of 52. Times, now we want another 10. Well, there aren't 4 10s. Now there's only 3 10s left in the deck, and there's only 51 cards left in the deck. So then it's going to be 4 times 3 is 12, and 52 times 51. Right, that's 2, 10, 15, and 1, 26, 52. You don't have to reduce fractions. I'm not too concerned about that. To get an ace would be 4 out of, oh, go back down. Get an ace would be 4 out of 52. Times, now we want a 10 or a face card. There are 4 10s and 4 jacks and 4 queens and 4 kings. So there's 16 face cards, but there are only 51 cards left. So that's going to be 64 out of 26, 52, assuming I multiply those right. All right, one more example. Back to our fish again. Remember there's 12 fish. The difference is this time we're not replacing them. That means to get reds would be 5 12s times, now we want a white, there's 3 whites, but there are no longer 12 fish in the tank. We took the first fish out. Now there's only 11 fish in the tank. So that's going to be 15 out of 132. To get a green and then another green, that would be there's 4 greens out of 12 to start. We took 1 green away, which means there's 3 out of 11 left. So now that's 12 out of 132. White, red, green, white, there's 3 12s. Times red, there's 5 11ths because we took 1 fish away. And then green would be 4 10ths because we now took another fish away. So if we multiply all those together, that's going to be 60 on top. And if we multiply the bottom, we're going to get 1,320. And then that would be your answer. So when items are dealt or drawn and are put back into the mix, we say they are being chosen with replacement. These are independent. When items are dealt and drawn and are not put back, we say they are being chosen without replacement. And these are dependent. All right, so remember for independent, you just multiply them together. For dependent, you have to take them away. One last set. This is without replacement. A 9 would be a 4 out of 52 times a king would be a 4 out of 51. A king and then another king. 4 out of 52 times 3 out of 51. The queen of hearts, there's only one of those. 1 out of 52. Times a face card. Now, how many face cards are there? Well, there's 12. But remember, we already took the queen away, and the queen's a face card. So that means there's only 11 face cards left out of 51. And then finally, a club or a diamond. So 13 out of 52 for clubs times 13 out of 51 for diamonds. And I would expect you to multiply all of these out. So 16 over 2, that's 10, that's 15, carry 1, 26, 52. This would be 12 over 26, 52. This would be 11 over 26, 52. And this would be 169 over 26, 52. Okay, so nice little summary down here at the bottom. Independent probability, you can read through these and kind of make sure that you take notes on this. so that you have them. Anytime you're doing practice problems, you can look back on this little sheet here, and then a couple little hints here for solving. All right, so tomorrow or whenever, hopefully Tuesday, you came to office hours. We're going to do the office hours practice problems, which are these guys. And then you're going to do independent practice 1 and independent practice 2 on your own. And then there's a homework assignment for you that I'm going to grade. So that's it for today, and I will see you in office hours.